Welcome to the Crazy Might Work podcast, where we celebrate authors, entrepreneurs, innovators, inventors, and scientists who live at the very frontiers of human consciousness and possibility. We discuss their moments of breakthrough and analyze the strategies they use to enhance their own thinking and challenge conventional wisdom. Our guest today is one of Australia's leading exponents of space biology and health. He's passionate about finding new ways to deal with debilitating diseases by applying engineering principles to unanswered biological questions. He was the 2020 Australia Space Award Researcher of the Year and is a committee member of the Australian Space Agency Space Medicine and Life Science Group to advise on the development of this exciting area of biology in Australia. He is also a senior lecturer and group leader of the School of Biomedical Engineering and the Faculty of Engineering and IT at UTS. And his innovative research focuses on developing different biological tools to understand cellular disease and in a particular field called mechanotransduction. Please join me in welcoming our guest today, Dr. Josh Chou. Welcome, Josh. So good to have you on the show with us today. It seems that you are spending more and more of your time these days just trying to build links between industry and academia, especially in this emerging space industry.
Yes, that's right. And thank you again for inviting me to come on your show. It's really great to come join here and share with everyone what we're doing here in terms of the space industry. And you're absolutely right. We've been really busy trying to, pull together everyone from, academia and the, emerging space industry. And really, we're seeing the rise of the emerging Australian space industry. And I think everyone would agree it's a very exciting times. And I think, what we really want to do is to raise awareness of, what's happening, and more importantly, what are the opportunities for, maybe industry that weren't traditionally linked with the space industry, but can have that transition to the space industry. So we're very excited and looking forward to it.
Thanks, Josh. So tell us a little bit about your area of research, this concept of mechanotransduction. What is that?
Yeah, so I'm a cell biologist by trade, and what we do is look at mechanotransduction. And what that really means, and I think everyone already understands this concept, is that mechanical signals in your body really dictates how healthy we are. So if you really think about exercise is good for you, your heart is always pumping, blood is flowing in your body. So if you really think about it, your body is one big mechanical machine. So really, mechanotransduction is the research and understanding of how mechanical signals and outputs and inputs affect your health in general. And
Josh, just as an example, can you tell us what you won the Research of the Year award for? What was that in this field, and what was it?
Yeah, so when we started off, we really looked at trying to understand how mechanotransduction play a role in diseases, and particularly cancer, because we know cancers are highly mechanosensitive. And what that means is, if you really think about it, cancers, they come together to form a tumor. It gets bigger, and at some point, there's some signaling that makes it invade out into the rest of the body. So we do understand that, cancers are very reliant on different types of mechanical signals. So, when we work in this area of, microgravity, which is the opposite of mechanical signal, because you're talking about weightlessness, lack of mechanical signal, we thought, what would happen to cancer in that kind of environment? And what we found was that it really disrupts their sensory mechanisms, their, survival mechanism, and basically how they function as a disease. So, I was fortunate to win that award for, developing that technology, the microgravity technology that enables researchers to be able to conduct this type of research and to answer a lot of these more complex questions and involving diseases that are aging diseases like osteoporosis, obviously cancers, and a whole lot of different biological questions that people have.
And Josh, from memory, there's an amazing backstory, isn't there, to how you focused in on this particular part of mechanotransduction?
Yeah, so I spent a couple of years over at Harvard Medical School where we worked on the project with a pharmaceutical company and NASA that look at developing osteoporotic drugs because astronauts lose a lot of bone, which is very similar to osteoporosis. And it was really during that time over there, I had the opportunity back then when Stephen Hawking was still around. One day I was having lunch on the board, and he was just around in the corner, and then he corrected my calculations and really gave an inspirational talk about what he thought about it. And then a couple of years later, when I came back to Australia, I remember it was summer, having my break over at the beach, and then what he said about nothing defies gravity, it really clicked in my head, and that really sparked that that idea into my head of, oh, okay, so how can we go about understanding diseases and normal human body function in that kind of environment.
So Josh, there are a couple of elements of that story that I think are interesting to unpick because they're actually amazingly common. When you look back at breakthrough insights over time, there are a couple of patterns that emerge from autobiographical or biographical stories of whether it's scientists or inventors, other kinds of innovators. But a couple of the things that I noticed in your story was first of all there's a cross-disciplinary interaction. So another example of this would be kind of DNA and the way that developed with just multiple different disciplinary inputs, expanding the thinking or leading it in various directions. I'm hearing that with that Stephen Hawking interaction, but then also sometimes there's quite a long search or incubation period. So the sort of thinking ticks over sometimes quite an extended period with focus in the general area, but maybe not with a huge amount of startling progress early on. And then the last thing is that quite often it seems that breakthrough tends to happen when the researcher or the inventor is actually outside of that lab or work environment. And I suppose just reflecting on those three things, I mean, first of all, are those true in the context of your story, and how common do you think that might be sort of more broadly across research or breakthrough thinking in general?
I think you've touched on all these critical elements, and looking back at my life and my career and my training, each segment of different stages in my life individually, it was important, but I think when it came together, especially now that I have my own lab and my own team, all these different trainings and different experiences, right now I'm relying on all these different experiences I had in the past to really culminate, these ideas to make it possible. So you're absolutely right when you said, this really takes time to incubate all those different concepts, ideas, strategies, and experiences. And then in the moment where you need it, it actually all comes together. I do think that, especially during these days, when people are really busy, you don't really often get that time of reflection and being just creative. And I can definitely attest to that, being an academic. So normally for me, it's normally during, the Christmas holiday when I have an extended period of time and break, that I can do a lot of these more creative thinking. And I think that's kind of dangerous because, leading into the new year, that's where I get my inspiration and my new ideas and plan for the new year, to really come together. But I think more on a daily scale, I always find activities and time where I can do and try to do creative things, that can really help stir that. I also think, as part of my experiences, and this is whether it be researchers or, people out there thinking about innovation and whatnot, is really limitations. I think, we are, well, at least how I was brought up, there was a lot of limitations to ideas, about whether things are feasible or not feasible. And of course, we all love to celebrate success, but we don't often enough celebrate failures, and we don't see that as success. So I think, if anything, I got trained on during my time at Harvard is that concept of not scared of failure. and more importantly, dreaming really, really big. When I was here in my undergrad, PhD, and whatnot, I would often share ideas. People would say, "Oh, that's crazy," or "That's impossible," and whatnot. Whereas the mentality at Harvard, when you have a crazy idea, people would say, "Well, how do we make it work? What do we need to get from A to B?" There was no, limits to where you can imagine, and you can definitely see why there are so much innovation coming out of Boston. Not only at Harvard, but MIT is there, and a lot of other great institutes are there. Is because of that mentality where they really push boundaries and celebrate failures, because that means it's one step closer to succeeding. So I think that mentality and training has really helped in my particular instance.
Yeah, it sounds like that permission to give something a try and to try working with things that are unusual, not established, is really crucial. And Josh, I noticed also with even just the name of your faculty, it's got a bit of biomedical engineering there. Obviously, you've got that biology background, but then there's engineering and IT. How important is that cross-disciplinary interaction, and how much of that is being now embraced by universities?
I think it's very important. I'm very lucky to be in this faculty because, like you said, it's very multidisciplinary, but together we're very collective, very, very strong and powerful, because I'm a cell biologist. I know my biology in and out, but there are experts in the faculty who are good with the engineering perspective, which I'm definitely not good at, and of course software. So we live in a world where software is equally important. Development of artificial intelligence. How do we leverage that into our pipeline and for biomedical discoveries and drug discovery, which we do. So if you really think about it, the whole process of innovation requires a multidisciplinary team, especially these days, no matter what industry you're in, and really, to be working in our faculty where we embrace and we have the expertise and the environment where people are used to working with and recognizing different people with different expertise and coming together to really solve or address a particular problem or solution. I think that's definitely something that that is the future, and we are seeing that there's a lot of promotion for academics and industry to get together to really solve problems for commercial or society as well. So I think having that background and that kind of work environment, I think is very critical to what we do.
Thanks, Josh. And I'm curious whether you mentioned that that often sort of that summer break is the the downtime. That's where some of your creative or reflective thinking happens, and where some of those new ideas emerge. But I'm just interested if outside of that, I suppose, structured break, whether there are any methods or activities that are your go-to when you really need to just get fresh headspace and rethink something.
Yeah, absolutely. I don't think I have a magic sauce for that. I do find that I'm most creative, one, in the shower, and two, when I'm cooking. I really do enjoy cooking because I think that also activates that creative side of your brain. But at the same time, you're in that kind of more relaxed state where you're not really thinking about work. So those are two of my more daily activities where I can step out of the zone, so to speak, and where I can kind of reflect and do some thinking. And definitely those are I've had innovative moments in during those activities than any other time, and other activities as well.
Thanks, Josh. I think we started working together back in around 2019 with the Australian Space Biology Symposium. And this is now 4 years later, and this year it's humans in space. And I was interested in what evolution you've seen during that time. Obviously there's been a change in branding of the event, but how much has it grown? Where's it going? What's your take on that?
Yeah, no. When we first started, the Australian Space Biology Symposium, it was really with the concept of bringing all together the researchers, the industry within Australia to come together, and have a platform where they can share and collaborate and whatnot. And then naturally, the following year, we partnered together with the Australian Space Health Symposium, because biology and health really goes hand in hand. And Dr. Rowena Christensen from the University of Melbourne, she's a world leading expert in space health, aerospace medicine as well. So it was very natural for us to band together our collective group and vision. Then, of course, COVID hit, and that kind of restricted it. But in essence, it allowed us to brand out and reach out to the global audience, because everyone was suddenly used to Zoom meetings and whatnot. And we really saw a big emergence in attendance. We had over 1,000 people attending. We had 128 speakers from all different parts of the world. So it was a really big success that we enjoyed. But it also showed, and it's a reflection of the importance, and also more importantly, the interest in space biology and healthcare. But I think back then people were interested, because we hear a lot of things from media, and we've seen in the last year or two there are more space tourists going to space and whatnot. But I think there's still a general lack of awareness of what it really involves. Why are we doing this? And I think people really want to understand, we're investing so much money in space. What is it actually for, and how does it benefit humanity overall? So we understand, recognize, we've been changing the branding over the last couple of years, and this year we changed to International Humans in Space Summit, and we've established a foundation. This is really to capture and encompass all the different elements of whether it be space biology or space health or space entrepreneurship under the one umbrella, where everyone can come together and collaborate and discuss about all the challenges and solutions that is required for human space flight. I think this year is very different. Again, different, and it's evolving every year. I see that because I work behind the scene. And this year, from the people that are registered, attending, we're starting to see companies that you wouldn't really associate being in space that are coming along. And I think that's a really positive sign that more traditional or conventional industries are recognizing that there are potential, there are opportunities, but they want to understand how to get involved. There must be a value for why they should be involved. And I think, this is starting to emerge. And I think, through different case studies and different examples of success stories, more and more industry are going to get on board. And I think we're really tapping into existing infrastructures and technology. It's not something that you need to recreate to be part of this industry. I think a lot of industry already possess that technology that can be translatable to space. It's just they don't know the process of have that pipeline, and that's what we really want to showcase. And we had a lot of feedback from industry from last year's conference, in which they had successes throughout this year, and it was due to our platform. So we're very proud of that heritage, and we really see in the next couple of years our platform and our summit will continue to grow, and be more inclusive of other more conventional and traditional industries.
I think, Josh, for many and for the uninitiated, space is still about a competition between middle-aged men, some not so middle-aged anymore. The thing that the Bezoses and Musks and Bransons. But really, it's less about space travel and more about, I guess, terrestrial, benefits of some of that research thinking, pushing boundaries. Can you give us some examples of that, perhaps, where where the benefits are sort of very direct and back on Earth?
Yeah, absolutely. And I think sometimes I think we overthink it. Space is just another environment. If you think about it, Antarctica is an extreme environment. Space is another extreme environment. So I always say to people, just because Canada Goose, they build winter jacket, does not mean they have to set up a shop in Antarctica to build that. They can make those jackets not being in Antarctica, but it has direct translational, commercial value to human beings in cold and extreme weather. So I think, there are a lot of, we should see space as that different environment, but how do we leverage and access it to help inform us to develop our products, our solutions, and whatnot. In the context of healthcare and, benefits to humanity, I touched briefly before osteoporosis. That's a big problem for everyone, shared by astronauts as well. And, long story short, Amgen, they developed an anti-osteoporotic drug because of that research, and that directly impacts, patients with osteoporosis. Another example I like to use is Merck, anti-cancer drug, Keytruda. This was a drug that required, I think it was like 2-3 hours of infusion for the patient. So you can imagine it's not a very pleasant process, but over a course of a period of time, they developed the drug in space where the microgravity changed the formulation of the drug, and it became much more efficient. So you only have to go in for an hour for the infusion. So that was direct benefit for the patient because it's, it benefits, their time and everything. Of course, it benefits Merck because, it's a much faster process, and also in terms of commercial value as well. So these are just two really quick direct translation. And what we are doing in terms of, what we do as a research and also through our company is really what else can we do with microgravity? We don't always have to do everything in space to leverage microgravity. And we develop a number of microgravity technology and platform that we can apply here on Earth for creating new things, developing drugs, screening for understanding diseases, and even now biomanufacturing. So those are very exciting things that we're hoping to introduce in the market in the next couple of years.
And Josh, I'm just interested in your own research, on microgravity. What are some of the potential applications of that? And have you had the opportunity to actually do that in space as yet?
Yes, we've had been able to do a couple of experiments in space and also parabolic flights and whatnot, and that really helps us to understand how cells behave and also developing the tools and technology. So, we see that there's a big gap of people being involved in this industry because there's no tools or access. So we have to build the platform. So we're starting from Earth and taking it step by step all the way up into space, developing those infrastructures that is necessary for this type of research innovation. So for us as a researcher, we really want to use this to understand how the human body and diseases really process or age, because microgravity accelerates the aging process. So if you think about it right now, we're developing treatments and drugs for diseases and conditions after we know what are the results of having those disease or condition and developing a drug to treat it. That's why it's called treatment. But what we want to do is to prevent it from happening in the first place. And the only way to do that is if we understand how your body or disease onsets and progress to that particular condition. So we're trying to leverage the microgravity to accelerate that process in hope of understanding so that we can develop preventative measures to prevent it in the first place.
Very exciting. And as you look forward to some of these global programs, think of the Artemis and then the Moon to Mars program, what opportunities do you think those will present for research and development?
Yeah, I'm actually involved in a lot of these programs. And look, I truly enjoy it because it's really pushing boundaries. Because you have limited resources and everything has to be perfect. So I do see a lot of opportunity, especially the moon, because it's obviously closer to Earth. And definitely you can see there are a lot of activities, both from government and private industries happening around the moon. Mars, there's definitely a lot more attractions now, and people are starting to plan for more missions to Mars, both from government and also private industries as well. And it really gives you an appreciation, when we do see these missions from happened. It actually took a span of 10 years or however many years it took to really prepare for that moment. So for example, right now we're talking about discussing about Mars mission, but this is not set for another 10 years. So there's a new level of appreciation on the complexity of these missions. But at the same time, it's also very exciting because you are really trying to push the boundaries of space exploration. And if you really add in that element of putting humans on the moon and Mars, that's definitely next level. And as exciting as that sounds, we haven't barely scratched the surface in terms of how do we actually keep the human alive even on the moon for extended period of time, because again it's a very remote, extreme type of environment, and currently we just don't have that basic understanding on that responses. So that's kind of where our research is really to try to understand those different gravitational conditions. Of course there's some gravity on the moon, but not complete weightlessness, but it's not the same on Earth. So what does that do to the human body? How does that affect the food, the medications that the astronauts will bring, and so on and so forth. So there's a lot of opportunities and for everyone to get involved.
Josh, if you were going to offer one piece of advice for someone who's either sort of early in their research career or perhaps wanting to get into some of these exciting opportunities, what would you say to them?
I would suggest them to come to our conference to get to know more about what's happening. And look, our conference we're not for profit conference. You can tell that for the last couple of years it's all been free and all the presentations is open access. So if there are someone that's interested or have an interest or curiosity, I would say have a look at all those great speakers that that shared from around the world to really understand which area that you're interested in, because it's really big. When you're talking about human, everything that we've developed in human history applies to it, whether it be food, moisturizers, cosmetics, clothing, everything. So I think there's a lot of entry points for researchers from all different elements to come on board. It does not have to be a biologist, does not have to be an engineer. Like you said, it's a multidisciplinary industry, which there are many entry points. And I encourage people to even just be curious to see what's happening and where you can see yourself fitting in or contributing into, because I definitely see there is always something that everyone can participate in.
Do you think there's any discipline or skill set or industry for that matter that has absolutely no role in space or in the space industry?
I don't think so. I think every industry has a role in the space industry. I think when people naturally talk about space industry, they think of engineering, but that's because it's all about rockets and satellites and whatnot. But we're evolving into where we're thinking about putting humans in space for extended period of time. So we have to think about these elements. And like I said, everything from, if we're talking about, women in space, there's definitely more women in space now. Concepts of, periods, how do we solve that problem? What strategies are there? And so that's why I said there is literally, I think every industry can contribute to the space, humans in space industry.
Fantastic. Thanks, Josh. I think that's a great all-inclusive note to finish on. Thank you so much for your time. It's been great chatting with you and very much looking forward to the Humans in Space Symposium.